How many solutions does this system of equations have? Well, when I see that x squared, I know that this is a parabola. All right, it's quadratic. I drew it upside down like this because I see the negative sign in front, so I know it's going to be a downward facing parabola. Y equals x plus 4. Notice that it's not squared or anything. That's because this is linear. All right, degree 1. This is a straight line. So this is going to be like this. Now, I don't know exactly how these are in relationship to each other, but I know I have a parabola and a line. So it's possible that I will have two solutions. All right, that's one possibility. So maybe it's two solutions. It is not possible that there could be three. If you have a line and a parabola, there's no way that they're going to touch in three places. So I know 3 is not the answer. There's no way there could be infinitely many. All right, now, so obviously it could be 2. What about none or 1? Both of those are possible. Okay, it could be none. Well, let me start with 1. If I had my line and it happened to hit just like this, it could have one solution like that. All right, so 1 is possible. Or if the line went like this and missed the parabola altogether, it could have none. There could be no solutions. So between A, B, and D, we need to explore more. And what I'm going to do is I'm just going to solve it. And the way I'm going to solve it is by substitution. So y equals negative 2x squared. So I could take this and substitute it in for y in the other equation. So if I did that, then this bottom equation, instead of being y equals x plus 4, it would become negative 2x squared equals x plus 4. All right, because I substituted the negative 2x squared for y, and now it's here. Now I have an equation that just has x's. This should be solvable. And the first thing I would do is I will add 2x squared to both sides. Okay, that's going to give me 0 is equal to 2x squared plus x plus 4. I can't combine these. They're not like terms, so I just moved it over and put the 2x squared in front. So now I need to solve this equation. Now, I will feel better if the 0 is on the right-hand side, so I hope that didn't bother you. My first move is I'm going to try to factor this. If it doesn't factor, I'm going to use the quadratic formula. So 2x squared can only factor as 2x and x. You know what? I don't think this is going to be factorable. I'm looking at the 4. Normally I would go like 2 times 2, but you can't have a common factor like this inside the parentheses, so I know that's not going to work without even thinking too hard. So the only other thing to do would be to go like maybe, well, I can't put the 4 there either for the same reason. So it would have to be 1 and 4, but that would give me inner of 1x and outer of 8x. There's no way I'm going to get 1 out of that. So this is not factorable, which makes me very sad because now I have to do the quadratic formula and the answers are going to be ugly. So that makes me very sad, but I have no choice. So the quadratic formula looks like this. X is going to equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is what you have to do when it won't factor. Let's see. So b is 1. So the first thing I'm going to do is I'm going to calculate my b squared minus 4ac. That's called the discriminant. Okay, so b squared minus 4ac. That is 1 squared minus 4 times 2 times 4. I'm going to calculate that. Okay. So I have 1 squared minus 4 times 2 times 4. 1, 4, 2, 4. Is that what I had? Yep. Boom. That is negative 31. Okay, that is very, very interesting because when I have a negative discriminant, remember that this discriminant lives under the radical. So if I go to do the rest of the problem, you know, with the whole opposite of b business, that would be negative 1 plus or minus square root of negative 31 all over 2a. 2 times 2 is 4. But what happens when you put a negative under a radical? You get imaginary numbers. So I'm going to have negative 1 plus or minus I radical 31 over 4. These are imaginary solutions. Imaginary solutions are not going to show up as intersection points. You know, when I'm talking about a parabola and a line meeting, you get imaginary solutions when there are no real solutions. All right, intersecting lines, those would be real solutions. So I'm getting imaginary numbers here, I radical 31, because these don't touch. Okay, so we are going to say none. Now, I'd be more comfortable when it says how many solutions does this system have? Well, you know what? Never mind my comfort. Imaginary solutions don't count when you're talking about a system because you need an ordered pair. There's no way I could get a y value to go with these imaginary x values, which is what these are. So imaginary solutions mean, when you're talking about a system, means no solution. So the answer is B.